Welcome to springlib.
In this question, we're going to find the inverse of the rotation matrix here, which comes from equation 7.13 in the text. And we should get the matrix C, which is in equation 11.14 in the text. And then we should also see that this matrix corresponds to a rotation in the plane through an angle of negative theta. So, since this is a 2x2 matrix, we know that there is a formula for its inverse. So for convenience, I'll just call that matrix A. And so A inverse will be 1 over the determinant of A multiplied by the matrix that you get by swapping the entries on the diagonal of A and taking the negative of the other terms, the non-diagonal terms. Now, what's the determinant of A? It's just the product of these two, cos squared of theta, minus the product of these two, which is negative sine squared of theta, meaning that the determinant is cos squared plus sine squared of the same angle. And that, by the Pythagorean identity, is just 1. And so we do get the matrix C with an angle theta as the inverse of A. And now we see that, or we can also see that A is the matrix C with this alpha being negative theta. So because this C represents a rotation in the plane through an angle of alpha, and cosine of negative theta is equal to cosine of theta, and sine of negative theta is negative sine of theta, A is just C with alpha being negative theta. So here if we have the negative theta, that would be this negative sine of theta, and this would also be flipped. And so that is it for this video. Thank you for watching, and I hope you found it helpful.